Good morning. I hope you are doing well. I am doing very well. I'm very happy with how everything went this week, and I've definitely learned a lot, and I think it's going to be extremely useful for moving forward. I'm very, very keen to show you what I've learned. It's, yeah, it's pretty good. Oh, what's all this? What's all this? Oh, sorry, hang on. I forgot I changed this. There we go. Alright, yes, Mocap Madness. More Mocap stuff this week. So, just as a quick recap, last week I mentioned that a bunch of things, but one of the things was that I was having a meeting that evening with one of the guys from QTM, the company, Qualisys, the company that makes the motion capture cameras that I've got, and my goodness, that man, he knows the software very well. He was so helpful. So Philip, if you're watching, thank you very, very much for that. That was extremely useful. And yes, turns out QTM is very powerful and can actually do everything that I wanted it to do and more. It's amazing. So let's have a look. I want to kind of give you the rundown partially so that I can retest my understanding and also so that you can see what it can do as well. I just realized the order in which I've done these things is a bit not ideal, but I'm just going to move something and hopefully you don't get to see it too much. It's a bit of a spoiler for later. But let me show you QTM. So here's the software. Open it up. And so this is business as usual. Like we've got the base down here. For some reason, I keep getting weird erroneous markers like these. And then if I just kind of like cover them up, they go away. Bit weird. I don't really know what's going on with that. But yeah, and it's like increasingly common now. Like that's not a marker. There's nothing there. Anyway, so we've got our rigid bodies here, but you'll notice, first thing, is that the global coordinate system, this big triad that we see here, is bang on the base's origin. How good is that? And that was done, for reference, when I did the calibration, I had the L bracket thing just like kind of dangling on the top of Jugglebot. It was at some like completely cooked angle. So I'll show you what that originally looked like. This is how I originally calibrated it. This is where it thought the coordinate system was based on where I put that L bracket. And then this is where Jugglebot actually is. So yeah, bit of a change. But it turns out there's some very, very cool things you can do with this. So the first thing that I did was in the 3D settings, in any rigid body that we create, we can move where its origin is. So for example, on the base, I can translate its rigid body to be in any given local coordinates, or I can move it so that the center, the origin of that rigid body is at the origin of some other rigid body, if you wanted to do that. You can also move it to the geometric center of the body of like all of the markers that you are using, which is what I was intending on using before. Or you can move it to a specific point, which is so good. Or you can go even further and you can say that so a given point is at a certain coordinate. So if I have a marker on one of these rigid bodies and I know for a fact that that marker is going to be at some given coordinate with respect to that rigid body's origin, I don't even need to have a marker at the origin. It doesn't even matter where any of the other markers are, as long as that one is in its known spot. All of the other ones can be completely randomized, and as long as that one's in its correct spot, we can just say, yep, this rigid body's origin is with respect to that known marker. We only need one, which is so good. And it gets even better than that. We're just getting started. You can also, if your rigid body is a sphere, then you can set it to be the spherical centroid of that body. And this is actually something that I'm curious about with regards to making the balls be tracked. One thing that I've thought about a little bit with these balls, where the whole ball is covered in tape, is that this is just treated as one big marker. As far as the cameras are concerned, this is just a circle from wherever it's viewed. And so that means that any rotation is not captured by the cameras. They can't see that rotation. However, if we instead covered the ball with like a whole bunch of little like polka dot dots all around it, and then set that to be a rigid body, then we could get the rotation as well, which I think could be interesting. I think, yeah, especially, I don't have any anything to show you with this, but John has noted, he's been doing some throw catch testing, and he's noted that these balls with like the sand or whatever it is inside them, they don't tend to fly super straight, even when the robot is throwing them up. Now, this is something that I've observed when I've used these balls personally, is that when I throw them, sometimes they follow kind of weird trajectories. But I've always chalked that up to when I throw, I tend to like roll the ball off my fingertips to give it a bit more oomph. And honestly, if you're ever practicing numbers juggling, always like use your fingers. Don't use the palm of your hand is not good. Your fingers, you can throw really high with just moving your fingers, and that's extremely useful to do. But that, for me at least, that always ends up spinning the ball. Like if I'm juggling like multicolored balls, the balls are just spinning like crazy. So I've always assumed that it was due to that spinning that this ball with the sand flies kind of weirdly. But it's interesting that John is noticing this happen with the robot throwing it, which is like just a perfect straight up throw. So it's kind of weird that it's not flying straight. But I'm thinking that maybe if we cover the ball in a whole bunch of little dots, then maybe we can get a bit more of an idea of, I don't know, how it's moving in the air, potentially. But anyway, let's continue. So this, what I've just shown so far, is how you can translate the origin of the rigid body. And this is what I've done. So I've gone in and I've said, okay, here is my base. And I've got some markers on here that weren't there last week, but I'll explain them in a bit. So this marker is actually not visible right now. Let me just make it. Okay, that's better. So this marker is number 17. So I can come in and I can say, yep, base number 17. I can come into my settings and I can translate the rigid body so that the origin is at base marker 17. And I don't want to do that now because I've already done it before. That's all well and good for translation, but that will... Actually, no, maybe I will show you, just so we can see what it looks like. Let's reset it. Yeah, right. I can just redo it. Yeah. So once we translate, that is what it looks like. So we have the local, like the rigid bodies coordinate system is parallel to the global coordinate system, which is obviously not what we want in this case. Like that's really not where we want the coordinate system to be. So what we can do is we can, as well as translating that coordinate system, we can rotate it. And I love these options that we've got here. So we can either rotate it by a given number of degrees or radians about whatever axis we want, or we can align it using the parts. And this is the option that I've been using. So what we can do is we can make the x-axis parallel to certain points, from one point being like negative x to a second point being positive x. And then we can also make either the y or the z axes either intersect a point when it's projected onto the YZ plane, or we can make it parallel to 2 points when they are projected onto a certain plane. And so what I've done is I've come through and I've said, this is all kind of twisted around now, so I don't know which one's which. But yeah, so this one is x, so we can say 2 to 6 is our x direction, and then our y direction will be 4 to 10. So hopefully I can remember that. And we can come into here and we can say rotate. Stop opening up there. X was from 2 to 6 and Y was from 4 to 10. Boom. Cool. So now our rigid bodies coordinate system is bang on where we want it to be. That is perfect. But what we really want to do, as I said last week, what we really, really want is to have all coordinates, what I was hoping for at least, is to have all coordinates that get sent through. So if I move this marker around, and if I get rid of me, you can see down the bottom right-hand corner, there is an unidentified marker, and that's this one that I'm spinning around. So if I go close to you, there you go, you can see it. as I'm moving that around, those coordinates that you're seeing, X, Y, Z, are with respect to the global coordinate system, which is that cooked angle. What I really want is I want to have all of the marker coordinates in terms of the base coordinate system. But it turns out you can't do that. You can't send unlabeled marker coordinates with respect to a certain rigid body's coordinate system. But you can do one better, as far as I'm concerned. This may not be useful in every application, but it is certainly very useful in mine. Because really, I actually don't care where the base is. Like, the base could be anywhere on the floor. I should be able to slide it around and it shouldn't matter. And Jugglebot's code it doesn't inherently need to know where that base is. It just needs to know where everything else is with respect to the base. So, a very, very cool thing that we can do is we can come into the cameras and we can transform the global coordinate system to be the same coordinate system of a certain rigid body. So here we just type in the name base, we fetch that rigid body, and we apply that, and then bang. All of a sudden, whoa, what just happened there? Let's try that again. Okay, I don't know what happened that first time. But now we can see our global coordinate system is bang on where the base coordinate system is. Even though the actual global coordinate system was at some screwed up angle. And this is amazing. This means that every time I move something around, so I've got my unlabeled marker here, that is now in the base coordinate system, because the base coordinate system is the same as the global coordinate system. It's so good. It's so, so good. Hello, Lawless. Sup? Cool. So one other thing that I wanted to do in the past was to get the when I'm streaming this data from my Windows 10 PC, which is what we're currently seeing, over to Jugglebot's computer. I would really like to, in the past at least, I was really hoping that I could send this labeled data as like the XYZ and residuals, as well as the label of like what rigid body that's a part of, because otherwise it's just like a big list, and that is the way that it is sent. It's just a big list where there's however many things there are here, 29 different trajectories, and they're all just in the same order that they are presented in here. And I figured, like, okay, that's fine. And also, by the way, if one of them is covered up, so if we, like this marker here, platform 2, this is covered up, rather than being just taken out of that list, it is still sent, but with like NaN, as like not a number as all of the fields. So I was thinking, like, okay, fine, that's all right. As long as I make sure that I don't muck around with the order in here, then I can always know which markers are for the base and which markers are for the platform or for any other rigid bodies. Which kind of works, but it does mean that if I change the order in here, it will muck things up. And to be honest, I only realized fairly recently that you can actually filter this list by the different values, and I have no idea what that does to the streaming data. I don't know if that affects it or not. So that would kind of mess things up. And also, if I delete and change rigid bodies around, then that's going to mess things up as well. But it turns out you can actually get this data, and I think it's, I don't know, now that I know how it works, I can kind of see how it makes sense, because as far as I'm aware, sending arbitrary strings can be fairly like data intense. Like if they are sending the string base with every single marker, like all, whatever it is, 17 base markers, if they're sending that string base with every single one, I can kind of see how that would kind of clog up the system. So rather than doing that, the way that QTM has handled all of this is that each of these rigid bodies gets like a hash code of some sort, and that hash is sent with all of the markers, and then you can access in QTM, there's some like XML script somewhere that has like the mapping between these hashes and the rigid body names. This is my understanding of how it works, at least. This does mean that to get this information is a little bit convoluted, but it works. So let me quickly hide some stuff that I don't want you to see until later. So let's bring in VNC. And yeah, so we've got this script which basically just like receives the the motion capture data, and we can see, let me just stop it because it's kind of erratic, and let me get rid of me. So we can see this is just streaming that data live, but we've got the right data. So like here is the body platform, and we can see the position and the rotation of the platform. And the same thing, I think for the base, no, for the base I haven't got it printing it, but just for the platform, I've got it printing both the position and the rotation of, yeah, that rigid body, which is so good. And you can do this with all the markers as well. So I can say like, if the marker is part of the rigid body, is part of the platform, then do this. But to be honest, I don't even need to look at any of the markers for any of the rigid bodies anymore, because I can just poll QTM for the centroid of that entire rigid body. And that allows me to do the position and the rotation of that rigid body, which is so good. Yeah, and it is a little bit of, I don't know, there's a bit of kind of setting up to get that, I think it's in here. Yeah, we have to like get all these parameters and create a dictionary between those parameters and the, that like hash, whatever it is. But it works. And yeah, so the guy that I spoke with last week shared with me a script that he made to do this, and I basically just like copied the bits that I wanted, and now it works, and I am so happy with that. However, there is one thing that I've noticed that is a bit strange, and this is something that I need to ask him about, which is that QTM really slows down, at least the real-time streaming really slows down once I get rigid bodies involved. And interestingly, as the number of cameras change, it also changes it. Bit odd. So if I get rid of me, you can see down in the bottom right here, we've got, in the very bottom right is the camera sampling rate. So that's 300 hertz. So the cameras are, yeah, sampling my space at 300 hertz. Next to that, we've got the real-time rate, which is the rate at which data is being streamed across the network. And that is currently 160 hertz, or 150-ish. Now, I don't know why that's going so fast now, especially because of the fact that I'm live streaming at the same time and have VNC open. But earlier, when I've had literally the exact same setup as this, but without VNC or streaming, that's been down at like 25 hertz. And I don't know why. And strangely, when I had the door open at one point, it was blocking one of the cameras and it was running at like 50 hertz. And then when I unblocked that camera, it went back down to like 25 hertz. So I don't really know what's going on there. I need to ask them about it and see what's happening. But yeah, I definitely want it to be faster than 100 hertz for sure. Like it should be, I've got it set so that it should be streaming over, I believe, at 200 or 300 hertz. And yeah, that would be great. But for some reason it's not. And it's only once I add the rigid bodies. Like if I, let me get rid of me again. And let's remove the rigid bodies so they're not enabled. Boom. Yeah, real-time streaming hops right back up to pretty much exactly 300 hertz. So it's as soon as we add those rigid bodies, it just canes it. And I don't really know why. Cool. Yeah, okay. So our platform rigid body is pretty cooked as well. But I'll talk about that in a sec. Yes, so QTM is incredible. And what I've learned from this is that if there is something that I want QTM to do, it's pretty damn likely that it can do it. It's just going to be a bit of figuring out how to do that. And to be honest, I think the real answer for me at least is just to ask support. Because I have found their documentation page is good. It's got a lot of stuff there. There's a couple documentation pages I've found, and it took me a little while to get to like the one that has the full protocol. But even then, there are things that this guy's script is using where I'm like, huh, that's an interesting like method. I wonder what other information I can get out of that method. And so I like go into the docs, Control F for those, like that exact phrase, and it just doesn't exist. And there's a lot of methods like that that are just like not in the docs at all. I'm like, all right, cool. I guess I'll just copy what Philip did and call it a day, which works. But yeah, I think I'm just gonna have to ask them for any help that I need. Yeah, but I mean, so far that's paid off pretty well. Cool. So one thing that this means is that we don't need to worry about having any kind of symmetry with the markers on the base. So last week I remarked that, last week the only way that I was aware of to set the rigid body of the origin of a rigid body is that it would just be like the centroid of all of the markers that make up that rigid body. And if that is the case, then that means that all of the all of the markers that are on the rigid body need to, if I want the origin to be in a specific spot, then I need to be very deliberate about where I put those markers so that the centroid of all of those markers is right on that origin, right where I want it. But because I can move the origin around to wherever I want, none of these markers need to have any symmetry at all anymore. And there's one other pretty cool thing that I want to just quickly mention before I forget. Is that in QTM, it doesn't support Space Mouse. I am so triggered by this. Like, they've got to add Space Mouse control to this. I keep going to grab my Space Mouse to move this viewer around. But anyway, one cool thing is that you can actually, as well as doing everything that I've shown you already, you can also add a virtual marker. So if I believe you can only do this in a recording. So let me show, yeah, I guess we'll just do this one, just as an example. Let me just quickly refresh. This is something I learned as well. You can what the heck? All right, things have changed. I shouldn't have done that. But you can add like virtual markers here. So if I have two markers, like let's say that there's a spot where I want my origin to be, but I can't put a marker there because it's annoying for whatever reason. And also I can't do that offset thing that I said before for some other unknown reason. What you can do is you can add a virtual marker that's like between 2 points. So I can create a new trajectory. I think. Maybe I need to check. I need to check up on how this works. But there is a way to create virtual markers that are like the average between a couple. So I can, in the meeting, the guy showed me with 2, and I believe you can do it with more, but you can basically select them and, okay. I need to double check how to actually do that. But yeah, you can add virtual markers. So if you have like a bunch of them around and you know that like the exact midpoint of those is a particular point of interest for you, then you can make that as though it were a marker. And of course, because like once you have the calibration of like this set of markers makes up a rigid body, you don't need all of those markers to be visible for the rigid body to be fit. So you can add all of these virtual markers, and once you're actually using that rigid body in the tracking, those virtual markers obviously will never actually have a marker associated with them, but because they are part of the larger rigid body, the other markers in that rigid body will be found, and then those virtual markers will also be found. Well, virtually found, I guess. No, don't save. Oh, just opened a new window. Okay. Yep. So I think that is very cool. I don't know if I will need to use that, but it's cool nonetheless. So yes, we can randomize all of the markers around the base except for the one where we want the origin to be. That one, we really want to be able to guarantee that it is in fact at the origin. So with that in mind, I have done some redesigning of some Jugglebot bits. So I mentioned last week that I lost the file for this part, which I still have. It's kind of annoying, I couldn't find it. But that's okay, because I was able to just recreate it. And you can see I've added some spots for markers. Now we've got one in the center, which should be bang on where the origin is. Like that should be spot on. And then we've also got 2 that are lining up in the y-axis and 2 that are lining up in the x-axis. And these markers, as long as these ones are where they are supposed to be, our origin will be completely fine. And then all of the other markers that are around the place that are only used for the purposes of finding this rigid body, those ones can be wherever the heck we want. Now, I fell quite in love with this method of attaching the markers to the base just by using these 2 holes. And now last week, the way that I was doing this was just with like straight ones, like, oh, I didn't change any of them. Lol. Yeah, these are all the same, aren't they? I haven't gone around and changed them all yet. Let me show you what they actually look like. So last week, the ones that I had were just straight, like this. And I had some that were like this, and then some that were like, if it will load, like this. And that way we guaranteed that like there was perfect symmetry all around the place. But now I have 6 different variants of these. So all the way around, we've got 6 spots for them to go. They each hold 2 markers, which means that we've got a total of 12 markers plus these 5. So we've got 17 markers on the base, which we saw before, which in my mind, that should be plenty to get a pretty good, like rock solid foundation for the cameras to kind of like link, like, yeah, associate with the robot. And to make sure that they're all randomized or like semi-randomized, I could just go around and like place markers willy-nilly, and honestly maybe that would be nicer, but I kind of like being able to just quickly add a whole bunch using this. Like it's fairly easy to just slap these like the double holders down. And yeah, so I've got inside the bolts, which look like this, and then outside the bolts, which looks like that. And then I've got a variety of angles. So you've got negative 15 degrees, which looks like that, or positive 30 degrees. And I believe that I haven't, I should actually do this, but I haven't actually gone into my code that I showed off last week to verify if the actual layout that I've used here is robust to all numbers of markers being covered up. To be honest, I haven't really worried about that because there's 17 markers there, and there is no way that I'm going to be covering up any more than like 3 at once, or maybe 4. So I feel pretty confident that this rigid body is not going to be going anywhere once it's being tracked properly. Now, there is actually, while I'm talking about that software, I feel obliged to note that someone, whose name I can't remember, in the YouTube comments, if you go back to the last live stream, the pinned comment is someone noting that they were very confident that my analysis code was incorrect, and they are absolutely correct that my code was incorrect. Yeah, the problem was that what that code was doing was it was basically taking in all of the marker positions that we've got and then getting rid of some number of those markers. So like, let's say at a given time, it might be getting rid of like 4 of those markers, and then it will say, okay, with these remaining 8 markers, can we fit this rigid body in an incorrect way? And that aspect was working well, except for the fact that when it got rid of those 4 markers, when it tried to fit the remaining 8 markers, it would not consider the positions of the 4 that have been taken out. So it was only fitting the 8 markers remaining with the spots where those 8 markers should be, which is not in fact how it actually worked. And yes, so that script was incorrect, and I'm just flagging that now in case, I don't know, anyone is using that for anything. It's definitely, it needs some changes to be made to be fully correct, which is part of the reason why I haven't worried too much about checking my current layout. But yes, so all of this is very good as long as we can guarantee the position of these 5 markers. If these 5 are good, then the other ones can be wherever the heck we want. So the question then becomes, how do we make sure that this part is made so that there are as few errors as possible? And also, actually, on that note, one thing that I have changed about this part, this was previously attached with magnets, which was so nice. It was so satisfying to just like lift it off and then slap it back down. But in the spirit of making everything as, I don't know, tight as possible, and especially for something that is the origin of the entire robot, it feels pretty important that that's kind of like locked down. So I've gotten rid of the magnets, which breaks my heart a little bit, but I've replaced them with screws now. So this is held in with 6 screws, and it is not going anywhere. But the question is, how do I get this thing out of CAD into the real world? Now, of course, like the easy answer is 3D printing, but you can't 3D print this. Why are all my sketches showing? They're hidden. Get out of here. Yeah, I can't 3D print this. I hate supports as well. I'm not, I mean, I don't know, maybe I can 3D print it with supports because it's on the inside, so it doesn't really matter, but I don't know. I don't like dealing with supports. So I have been trying to, my thinking was, okay, I can get this like SLS resin printed, but I sent this off to JLC 3DP to have it made, and they came back saying, like this part has a pretty high chance of warpage. And I was like, ah, crap. I don't really want warpage. I want everything to be as precise as possible. Ideally, this hole and like these 5 holes will be like within like 0.1 millimeters of where they're supposed to be. And that way, like this is the foundation of the robot. This part needs to be spot on. Maybe. We'll talk about why it's maybe in a bit. But yeah, I really want this to be spot on. And so yeah, warping is not good. They've suggested that if I increase the wall thickness, because right now it is kind of thin. It's like 2 mils, I think. Yeah, 2 mils. I think the whole way around. Yeah. They said if I increase the wall thickness to like 5, I think they said, then it will have less chance of warping. But I'm like, less chance is not no chance, and I kind of want no chance. So I don't know. I asked about CNCing. They haven't replied to that. I feel like that would be a little bit expensive, but also if they're sponsoring me, then it doesn't really matter. I don't know. If you guys have any thoughts on how to manufacture this, maybe I should just try 3D printing it with supports. I don't know. I'm all this. So for reference as well, what I've got right now, I've printed this off, except I sliced it. Did I still keep that? No, I didn't. I basically cut it off here. So I split. I did this so that I could print it that way, and that worked fine, I guess. I haven't measured anything, so I don't know exactly where everything actually is, but that way I could at least just print it. So none of these markers are where they actually are supposed to be. So like the origin of Jugglebot right now that I showed in the software just before is not the actual origin of Jugglebot, which is a very important point for something I'm going to show a bit later. But yeah, so what I've got now on there is that white bit, and it's white so that I know that it's wrong and it needs to be changed at some point. And that seems to be working alright. One thing actually that I am a little bit, I was not really expecting to be an issue is that twisty cable that's wrapping around is actually blocking the markers sometimes. And like, so like before when I was trying to click on the origin marker and I couldn't click on it, it was because the cable was in the way. I'm kind of hoping that once I swap to this design, the middle one at least will be propped up enough that it won't matter. But to be honest, I'm not too worried about it overall because, as I said before, any individual marker doesn't need to be seen for the motion capture camera software to know where that marker should be, as long as that marker is part of a rigid body. Okay, I need a drink of water. So, what is next? Let's see. Let's go to here. Yes, how to manufacture that part. I am not certain. I feel like CNCing surely would have the least error. It might just be a bit expensive, but yeah, that's not really it's not really my problem. Unless it's too much. Yes, so we don't need any symmetry at all, which is amazing. I'm a big fan. And I'm pretty sure that more markers is better. I'm kind of wondering that potentially the lag, or like the slowness that we're observing with the real-time streaming could be a function of how many markers we're tracking. Like right now we have 29 markers as part of 2 rigid bodies, and that, I don't know, that's not none, I guess. I don't know how many it takes to kind of like slow the system down. One thing that the first Qualisys guy who visited here mentioned is that I will functionally never hit the limit of how many markers can be tracked. Like, I think it's like in the hundreds that are capable of being tracked. So I can't imagine that 29 with 2 rigid bodies would slow the system down that much. We'll see. Maybe I'm kind of thinking I might just need to give my computer a bit more memory so that it can process all this a bit better, but yeah, we'll see. Cool. The next thing is what I didn't want to spoil before, so just give me one sec. Because I don't want to have to go around and individually cover up all of these markers every time I do the calibration of the motion capture cameras. I should have started this in a different order. When I am doing the calibration, one sec, involving these two tools, this one sets the X and Y axes, so this is the Y axis and this is the X axis. This will be where the origin is. The way that the calibration works is I basically put this somewhere. Ideally, yeah, wherever I put this, that will be where the origin is. This will be the Y-axis, this will be the X-axis. I put this somewhere, and then I wave this wand around, which has a very, it has a known length between these two markers, and I need to be really careful to not mess that up. Yeah, I wave this wand around a bit, and then the cameras know exactly where they are with respect to each other, and that means that all future recordings are precise. The tricky thing though is that you need to make sure that no other markers are visible in the space when you're doing that recording. And now that I've got so many markers on Jugglebot, it will be a massive pain to go around and cover them all up individually somehow every single time I have to do this every single time I have to do this calibration, which at the moment is probably like once a week or once every 2 weeks, and maybe I should be doing it more frequently, but it seems to be working fine. But yeah, that covering up is kind of annoying. Also, something I haven't really spoken too much about is the Jugglebot is it just gets covered in dust and cat hair. That whole base is covered in cat hair, which is no good. So I was hoping that I can kill two birds with one stone and make a cover for Jugglebot so that I can cover it up when I'm doing the calibrations, and also cover it up when if I'm not using it for like a day or two, then I can just cover it up and no dust will get in there. And so this is what I came up with. I'm very proud with this actually. Ooh, a bit too close there. Let's zoom out a bit. So I made a little fabric cover, and I'm a big fan of it. Of course, I've been thinking of adding some like piano wire or something into that bottom seam so that it can kind of like stay out a bit. But overall, I'm super happy with this. I just kind of did what made sense on the fly, and I think this is the first sewing project I've done in a very long time where I didn't make a single mistake. I didn't have to unpick anything, which is lovely. I fucking hate having to unpick stuff. It's the worst. And of course, it is a bit rough around the edges, especially the top bit is kind of like where all of these pieces meet is not pretty, but it works. And it's so good. I really like it. I don't know if I can show you. I can show you the front view a bit better. Maybe you can see that a bit. I think it turned out quite nice, and I quite like that fabric. Whoop, whoop, there we go. Oh, there you go. Front view as well. Yeah, I'm pretty happy with this. But all is not well, necessarily, because it is the perfect cover for Jugglebot, or it's also the perfect den for Albie, who has a couple times I've been in here doing work, the cover's been on, and I've heard like a little, like, I don't know, a weird sound. I'm like, oh, what is that sound? Albie just loves to just sit in here. He doesn't even, as far as I'm aware, he's not doing anything. I think, thankfully, that my cat's obsession with munching on the markers, I think that was a temporary thing. I'm kind of hoping that they've gotten used to what the markers are now and they're just kind of leaving them alone. But Albie at least was playing nice when I was watching him. At least he wasn't trying to munch on them. But he's just sitting in there being so cute, and I can kind of see where he's coming from. I can see how that would be pretty cool to just like sit in a little covered den that's kind of still bright, but covered and protected. I don't get how, like, there's no space there. I don't even know. Yeah, there's very, very little space that's not covered in stuff. But he loves it. So I can't be too angry at him. He's just so cute. Okay, so next thing is how to know the, and actually with this, I've been thinking that maybe I can add like a skirt around the very bottom, because you can see that the very bottom of the cover only just extends down to the base. I've been thinking that maybe I can attach a little skirt the whole way around, and that way if I really want to keep the cats out, I can just tuck that in underneath. Or I could add magnets into that hem, and then the magnets would just kind of like snap onto the base, which will be pretty cool. But I don't know. I'll see how I go. Keeping the cat hair out was a good advantage of this, and if he's hanging out in there, that's not really going to keep the cat hair out. But yeah, we'll see. Good to see you, James. Finally catching another stream live. Very nice. It's not a juggling robot, it's a cat tent that also juggles. Yes, that's right. Yep. Can't get rid of him. Yeah, okay. So with all of this new information that I have with how the tracking software works, an important question to ask is how can we know where the centroid of the platform is? So we can find the centroid of the base, all well and good, with that that part that holds the origin marker right where we want it. But unfortunately, on the platform, I don't trust any of that geometry to be like correct. So let me uncover this, and yeah, let's leave that there for now. And yeah, so as well as me not really trusting any of the geometry to be correct, there are very few kind of like lock-on positions. There are very few positions on the platform where I can say, yep, I know for sure that's where that part is. So if I'll show you in the CAD. I think it might be easiest. Also, by the way, if you want to check out any of this CAD, then there's a link in the description where you can play around with it and do whatever you want. You can make the 11th copy, or give me the 4th thumbs up. Thumbs up are always good. Yeah, so let's go to this. A bit of a spoiler. So this is what the platform is supposed to look like, and it does. If you're just looking at it, then yeah, this is what it looks like. But these carbon fiber rods are supposed to be a certain length into these 3D printed parts, and similarly, they are on this, where this whole carbon fiber frame attaches to the 2020 extrusion is supposed to be at a particular spot. And this is all supposed to be in and the carbon fiber, the 2020 extrusion is supposed to be a certain length. I don't think any of that is necessarily to the micrometer true. The 2020 extrusion is definitely not the length that it's supposed to be, because I cut that by hand with a hacksaw. So that's not less than 0.5 millimeter correct. The only thing that I do know for sure, I guess, is the length of the linear rail. But even then, the position of that linear rail on the 2020 extrusion is probably not spot on. When I was making this frame, that was pretty damn stressful, I've got to say. All of these carbon fiber tubes are glued into the printed joints, and I am fairly sure that they are not all in the entire way in. I obviously tried to get them in as far as I could, but pushing all of these points together at the same time was kind of hard to do, and I don't know that they all are perfectly seated in. So yeah, all of this means that it's very hard to know how to lock on to the geometry of this part. If we knew for sure that this top part was a given offset from the centroid of the platform, which for reference is here. So this point here, this is the centroid where we want the centroid of the platform to be on the tracking software. If we know where any point is for sure with respect to that, then we're golden, because we can go into the motion capture software and we can say, yep, platform point 7 or whatever it is has these coordinates with respect to the platform centroid. But I don't know of any of those points where we can actually do that, which makes things a bit tricky. So what I've come up with is something that should hopefully work, which is to kind of hope that at least these 3 carbon fiber tubes, the horizontal ones, are in fact more or less horizontal, and if they're not, then they kind of average each other out and are equally, I don't know, they that together, if we kind of average all of those out, then hopefully this position here is in fact directly over the centroid of the platform. So now I can say, okay, this point here is however many millimeters. above center distance, 13.3 millimeters above the actual centroid. And we can say, yep, that is where the centroid is. Of course, we can't leave this little frame here in when Jugglebot's in actual operation because the hand is going to smack right into it. However, we don't actually, that doesn't matter because we only need to have this little frame there when we're doing that first initial calibration or like recording. So we take a recording of where all the markers are, and then in the tracking software, we can select a bunch of markers and say, yep, these markers make up this rigid body. And then in the future, we don't need any of those, any individual markers there don't need to be tracked. As long as enough of them are being tracked, then the entire rigid body can be fit, and the tracking software can like virtually put in this marker in that exact same spot, even though it's not actually there in real life, which is super cool. I'm a big fan of that. And yeah, so that's what I have done already. So let's put this away again and bring back this. Now, unfortunately, well, I guess maybe not unfortunately, we can do it again in real time. Earlier when I reset the rotations of the rigid bodies, the platform one got reset as well. So now this like XYZ triad that we see here, this is aligned with the global coordinate system triad, which was at that funky angle from before. Now we can see that the origin of the platform has already been transformed to that point, which is good. But the rotation is incorrect. So we can do the same thing that we did before. Now, what we need to do is we need to keep track of which markers we want to indicate the x-axis and which markers we want to indicate the y-axis. God, I wish the Space Mouse was supported in this. But yeah, so we want the x-axis to be in the same direction as the base one. So we want the x to go from... So yeah, what I've been... The way that I've been doing this... this reorienting so far is by using the marker tape markers that I've put on the platform, which I haven't put in the CAD yet, and I hope to at some point. But the TLDR is that I've got little strips of tape. Maybe I can actually show you on this view. Yeah, you can see them there. I've got little strips of tape on the ends of a bunch of those tubes. Not all of them, just a bunch of them. It probably should be on all of them, but I didn't... Yeah, I had erroneous understanding earlier, so that's why I did it like that. But those markers, those little strips of tape, I'm thinking of using those as a way of orienting our axes here. So like this rod, I'm just kind of hoping... Let's actually, if we go into the big assembly, we can see how these things are oriented. So we can see our main triad down there. This rod is aligned with the x-axis, so I'm hoping to use that one as the x-axis. But there is no rod in line with the y-axis, which is pointing forwards. However, when you do this like realignment thing, when you're doing that rotation, the software asks you to find, for the y-axis at least, it asks you to find 2 points that when projected into the YZ plane, then make up the y-axis. So they get rid of all of the x coordinates. So what I've been thinking of doing is, or what I've so far been doing, is there's a bit of tape on this point here, and then a bit of tape on the front one there. Those should, maybe, be horizontal to each other. And so if we get rid of the x coordinate of those 2 points, they will perfectly make up the y-axis, if they are in fact horizontal to each other, which is maybe in a bit of an assumption, but yeah, we'll see. So what that means in terms of this software is we say the x-axis is from this point, which is 9, up to 3, is the x-axis from 9 to 3, and then the y-axis is this guy back here, which is 4 up to the same one here, which is 3. So we're going 9 to 3 and then 4 to 3. So let's come back in, 6 off tracking. And also you can see all the other things. You can do gaze tracking in this. If you have like eye tracking cameras, you can track your gaze as you look around, which is pretty wild. We wanted to rotate. Oh man, I think I might have forgotten the numbers. So we want the X to be from 9 to 3, and then the Y from 4 to 3. Okay, okay. Perfect. So now that should be perfectly lined up. Of course, I don't have any way to actually verify that it is or not, but that looks pretty good. Yeah, it's kind of yeah. It would be great if I had like some sort of reference frame to put on there to then just verify this is correct. And honestly, maybe I will do the same thing with this, but I'll add more markers onto it so that I can check this triad a bit more closely. But that, visually at least, looks pretty decent. So that's what I've been doing so far with the platform. It doesn't feel super good, to be honest, but it's alright. And actually, one thing before I get to comments, one thing that Philip, the Qualisys guy, suggested is actually, I'll go to the camera view, that one. You can see how what I've done here is the markers on the platform are just little rectangles of tape that I've wrapped around the carbon fiber tubes. And that works well in my experience. However, Philip noted that by making these wrapped around cylinders, this means that any viewpoint that we get is just going to be seeing a rectangle. And the QTM software is looking for circles, and it will try to find the centroid of a circle. And what this means is that when it sees a rectangle, it's probably not going to get the exact spot on center, but also if we rotate that cylinder around, then the center point is going to kind of be on the surface of that cylinder. So as we rotate that cylinder around, the center point is not going to be at the actual center of that cylinder. Instead, it's going to be at the center of the rectangle that's on the surface of the cylinder. So his suggestion was, at the end of the day, his suggestion was that like these cameras can be used for a whole lot of different things, and people use them in very different ways based on their contexts. And a phrase that he kept returning back to is, if it works for you, then great, done. Because something that will work really well for one person's setup will not necessarily work really well for another person's setup. So he suggested exploring different options and trying different things, and then just finding what works for me and just sticking with that. And one of the suggestions that he had is rather than using these strips wrapped around the carbon fiber tubes, instead we can cut out little circles, like punch out little dots, and then put those dots everywhere. And that way those circles will always be a circle, and the center of that circle will always be like at the actual center of that circle, rather than kind of being offset as the cylinder rotates around. So maybe that will work better. We'll have to experiment and find out. So, comments. James says, you can verify the frame perimeter is an equilateral triangle by using string to measure the circumference, mark the string into thirds, and then compare against the corners. Interesting. Okay, let's have a look. So let's just look at the platform. Maybe. I believe it is. Yeah, no, it is an equilateral triangle. That is correct. Wrapping the string around might be a bit tricky though. These joints are in the way. It'll get pretty close. But even then, what would that even tell me? Like, even if I know that that is an equilateral triangle, and it is correct, I guess we would at least know that those nodes are either, they're all the same, so they're all like the same amount right or wrong. It would be great if I could just if I had like a 3D scanner and I could just scan this in like 0.1 millimeter resolution and just put it in and say, and like put it into my CAD and then compare. I think that would be ideal. But I don't know. I think that would work for telling me that until the leg length is equal, so the center is aligned. Okay, actually, yeah. So for this part, you're right. Yep. That's a good idea. I should do that just to verify. Yeah, no, that's a good idea. Thank you, James. Yeah, that works really well with this marker holder. John says, why not put a ball in the hand the center of stroke to define the platform coordinate system origin. Okay, that is an interesting point, actually. So, yeah, what I have been planning to do so far is to set the platform centroid to be that sketch that I showed before. This one. So that this would be the centroid of the platform. Now that spot has particular significance. It might seem like a kind of arbitrary point, but you can kind of see there's a bit of something going on there. That point has particular significance because that is exactly the plane at which the legs attach. And that plane is important for the inverse kinematics of moving the Stewart platform around. But, whoa, hopefully not like that. But that point has very little significance for the purpose of the hand moving around. And let's go on the platform view so we don't have that moving around so much. Now for the hand, I've been planning to just use a separate offset, so that way I can calibrate it, probably with the ball in the hand, and like the tracked ball in the hand, and move it the whole way either up or down, probably up so that it's not getting blocked by this tube. I can just move it to a known location and then say, yep, the hand 0 point, which would be down the bottom, is here with respect to the platform origin. Now, I think what John is suggesting is to put a ball in the hand in the center of the stroke. So that would be, I don't know, there-ish. And then use that point to be the platform coordinate system. That, I can see how that would be helpful for the hand, but I think I'd prefer to leave all of the inverse kinematic stuff as clean as possible by having those, like having the base centroid in line with where the legs attach to the base, and the platform centroid in line with where the legs attach to the platform. I kind of like that. Yeah, but you are right that by moving the hand to the center of its stroke, then that way we have like a kind of known, repeatable position, like mechanically speaking. Yeah, interesting. I'll have a think about that. John also says, I'm not convinced the absolute orientation of the platform matters much. You can take care of the offset and then your calibration is just relative to a 0 reference point you can pretty arbitrarily define. I'm not convinced the absolute orientation of the platform matters much. You can tear the offset. Yeah, the orientation... Well, okay, yeah. In actual use, the orientation of the platform, as far as the cameras see, is potentially not that significant. However, it's very, very helpful for something that I'm about to show you soon. I think it's next. Okay. So yeah, possibility is align the x-axis with the front two markers. I already showed you this. Okay, yes, so the next thing is we're getting the first steps to calibrating the robot, which is so good. But I need to have a drink of water first. Now, for context here, something they didn't teach me in Stewart Platform School, or the internet school of Stewart Platforms, literally nowhere on the internet, I searched for a long time about how to build Stewart platforms, inverse kinematics of Stewart platforms, different designs that people have made, what geometry you should pick to get the outcome that you want. I've done a lot of Googling of Stewart platforms, and not once, at least initially, did I encounter the fact that Stewart platforms, if you want the platform to be positioned in a very particular spot, the geometry of the robot needs to be like spot on. It needs to be so precise so that your computer model, like your inverse kinematics model knows exactly where everything on the actual robot is. If anything on the actual robot is just a little bit off, like if one of the legs, rather than being positioned here, is like positioned there, that can change things a lot. So someone on Zulip, probably like 2/3 of the way through last year, or halfway through last year, found a paper that explores this. They basically take I believe it was like a commercial Stewart platform, or in some fashion like a proper pretty legit looking Stewart platform, and they got it to move around, and they had like some kind of laser system to track where it was actually moving, and that system was extremely precise. And they found that even though this is kind of, I don't know, changing the order of things around a little bit, they found that even though the biggest error in any of the geometry of the platform was something like 0.5 millimeter, like one joint was like 0.5 millimeter out of place, or like all the joints were a little bit off, but the biggest error was around 0.5 millimeter, I think. The platform, as it was moving around, experienced the largest error of almost 15 millimeters. And when I read that, I was like, oh, crap. Because my robot is absolutely more than 0.5 millimeter off in the worst case. Like, this is all 3D printed and put together by hand, and like it's not super precise by any means, which is a bit of a problem. However, the good thing is that in this paper, and it turns out there's actually a couple of these papers, like people have different approaches for doing this. They walk through their approach, or all the different papers go through their different approaches for compensating for this. So usually what this looks like is you get the platform to move around to a whole bunch of known positions, and then you track somehow where it actually is, and then you use some process, they all tend to do it a bit differently, use some process to figure out where the robot actually is. Like, where is the robot, so that, like, how is the robot made so that when you tell it to move to 40 millimeters, we actually get the position that we measured. And this is what we're working towards. And once this, also for the reference, I've put a link to that paper in the description below. So if you want to check it out, you can. What this means for the robot is that right now, if we tell the robot to move to like 100 millimeters to the right, I feel very low certainty, or very low confidence, that it is actually moving 100 millimeters just to the right. It might be moving up a little bit, it might be tilting a little bit, it probably is moving forward or backward a little bit as well. So it's not moving exactly to where I want it to go. And if anyone, presumably some number of people watching this have juggled in the past, you might know how important it is for your hand to be in the correct position when you're trying to catch, or even when you're trying to throw. Like, that positioning is fairly important. I would say it's very important. And yeah, so this is no good. The fact that the platform is not moving to where we want it to move is a big problem. James says errors in dimensional accuracy multiply as their count goes up as well. Interesting. Yeah, so having multiple things be off makes them all worse. Which, yeah, that kind of checks out, I think. I can see that. So my idea here, what these first steps involve, what I've done so far, is to actually, just quickly, we now have a way to get all of the markers that are being tracked in terms of the robot's coordinate system. Fantastic. We also have the platform that is being tracked as a rigid body. We know where its origin is, yeah, ish. We also know what its orientation is, ish. But we're getting there. I feel we can at least in principle know where that point is. So what this means is that we can do exactly the process that I just described, where we move the platform to a specific location. We know in the code where we're trying to move it to, and we know from the cameras where we are actually moving it to. So this is the idea. Yeah, move the platform and track it with the motion capture. And this is where we get, let's just do this way I can show you me as well. We have plot juggler, and this is where we get that sad face that hopefully you could see in the thumbnail. I was trying to like make the line thickness a bit bigger on this to get the thumbnail to be a bit more obvious, but I couldn't figure out how to do that. But yeah, so here we have a couple plots. The main one, let me just show you. Let's get rid of these rotations for now. And let me move this away. Okay. Yeah, so this top plot is the Y position against the X position. So this is like, if we were looking down from above, from the roof, at what Jugglebot was doing, then this is the pattern that we would see it follow. And down the bottom here, we've got the Z position. And we can see as we move through, well, you can just see straight off that the motion capture, which unsurprisingly is the messy red data, is kind of far off the commanded data. So the commanded one is the blue, nice, clean, crisp lines, beautiful. That's what we want to see. Oops, sorry. But unfortunately, the motion capture data is not spot on. In a very strange way. Like the mouth is pretty close, but the eyes are off in like opposite directions. They're kind of like, they're both forward, but they're both kind of like pushing out as well. And yeah, I need to do a lot of looking into how, well, yeah, I need to be very careful about how I'm like laying out these points. But to be honest, I only got this working yesterday, and I was up pretty late last night trying to get this sad face to work because I wanted this to be in the thumbnail. But yeah, this is the, I don't know, you're experiencing it live with me almost. Yeah, so the Z data is fairly close. Like as I pan through, I think this is the biggest error. It's about 6 millimeters off, actually just over 5 millimeters off. So that Z data is like okay, but the XY data is not fantastic. I don't know how to select on here. James is saying one leg is a different length. That's why the red circles are offset. You reckon it's just one? Oh, okay, alright. So let's actually, we can test this. You got a hypothesis? Let's test your hypothesis. So, we don't want the mocap data, we want robot state. So we can look at the leg length data. So these are the commanded positions of all the legs. Once it loads. Yep. And then we can look at the actual position of all the legs. I'm gonna have to grab these. Oh, actually I can search in this, can't I? Look at me. Pro plot juggler user. Still have to expand them all though. Yeah. Alright. Oh, nope. Alright, this might be a bit messy, but let's see how we go. Okay. I don't know, man. They look pretty... what is the orientation of the bot against the graph on the sad face? That is a good question, to be honest. So actually, let's... so I made this, I haven't put this on GitHub yet, but I'll make sure it's on GitHub after this stream ends. I've got this script to generate our poses, and so we've got like, these are the same, I basically just copied this from when we did this, I don't know, like a year ago with just the tilt measuring. So we can do the same like layout as we had before, or we can also draw the sad face, which did not draw. Why did you not draw? Let's just not draw that one. Oh. Ah, okay. Sorry, I changed some things last night. There we go, that should work. So yeah, what is the orientation? This is the orientation. So we've got X and Y, and this is like the robot X and Y. So yeah, this is right. I'll bring up the, maybe we can do this at the same time. Get rid of this. Oops. Yeah. So that's like that. So the frown is like at the back here, and the eyes are up here. Yeah, and yeah, I do like your hypothesis about the legs, but I'm not sure. They look like there is an interesting stair stepping going on there, but they all look similarly on or off. To be honest, there's obviously something wrong. Like clearly, X is green, right? No, Y is green. X is red. Isn't that not the normal orientation? I always thought X is red. Anyway, yeah, yeah, there's clearly something wrong, but I am more. That's better. I'm more thinking that it is just to do with the geometry of the robot. So clearly, there are some positions that are wrong here. And also, for reference, there are a total of 42 different geometry coordinates that matter here. So for every single base, those 42 positions are all of the base nodes, of which there are 6, have an XYZ coordinate, so that makes up 18. All of the platform coordinates, of which there are 6, have an XYZ coordinate, which makes up another 18, so up to 36. And then the remaining 6 are the like shortest length of all of the legs. So when all of the legs are as compressed as they can possibly be, how long are they? Now, to James's point, I do think it's fairly likely that not all 6 legs are the exact same length when they are as short as possible, especially because at the bottom of each leg is just like a little foam piece that I'm using to kind of like, when the legs go through their homing sequence, they run down until they hit that foam, and then the motors like can't go any further, and so the current in the motor will spike. The O drive detects that spike in current and then says, yep, I'm at the end stop. I don't want that collision to be like a rough, hard, rigid collision, so I've added that piece of foam in there. But over time, those legs have homed slightly differently for whatever reason, and some of those foam pieces are more squished than others, which of course means that all of the legs, when they are homed, are all slightly different lengths. Not to mention the fact that, again, this is all made by hand, and so errors can compound. Yeah, so I do think it's fairly likely that not all the legs are the same shortest length, and that could be causing this. And to be honest, that would not be showing up in this data here. This is just showing whether the leg is moving to where I am commanding it to move to. So it is very possible that one of the legs is in fact, or even more of the legs are longer or shorter than the others. That would not be showing up here, so James could be completely spot on with that. I think he's correct, as well as probably the base nodes and the platform nodes are also probably not correct. Now, this raises the question of something that I said earlier about the base part that is holding... let me bring it up again. This guy. I mentioned before that I want this part to be as precisely manufactured as possible so that it will have that center marker be spot on the origin of the base. I think that that would be very nice if that is the case, but I'm actually not 100% sure that it is absolutely critical, because if we are going through this process of figuring out where all of the nodes are with respect to whatever origin we want, then it shouldn't matter where that origin actually is. So this process of calibration should be able to find where all of those nodes actually are in reality with respect to any arbitrary origin, I think. But yeah, I think it would be good if it was as close as possible. James is saying the top would be skewed if one leg were off from the other in the bot itself. If you can identify a compensation, you could tune the bot to accommodate the different base offset. Yes, that's exactly right. If you can identify a compensation, you can tune the bot to accommodate the different base offset. That's the goal. So yeah, the plan here is to have the robot... This sad face was a bit of a meme just for the sake of the thumbnail. I'm kind of hoping that maybe, no, probably not next week, but at some point in the future, we will have a happy face thumbnail with the red and the blue lines perfectly superimposed on each other, which will be great. Hopefully. Yeah, but the idea would be that we get the platform to move around to some number of positions. I don't know how many yet. I'm going to reread this paper and also check out a couple of the other ones that I found. But the TLDR is basically move the platform to heaps and heaps of positions and orientations as well. And then I believe the brute force way to do this would basically say, okay, those 42 unknowns, they should be, like, we can give it a bit of a head start. We can say, like, yeah, they should be around here with like a given sphere of error. but they are not exactly there. And then just go through and brute force, try every combination of 42 geometries, which this would functionally not work. I think I would have to be leaving my computer running for like 6 months to finish this simulation. But a more sophisticated version of this, I think a more clever version, of basically, just trying every single combination of those 42 geometries and then seeing which of those combinations matches the actual outcome the best. And a key point here is that we need to know how long all of the legs were in that movement. So we say, okay, the robot has some given unknown geometry. It moves the legs to be these lengths that we see here. So it's moving the legs to be at these given lengths, and the end result is that the platform moves to wherever we see here. So then we say, okay, if we have this given geometry that we are analyzing right now, so some variant of what it's supposed to be. If we have that combination of geometries and we move those legs to be the given lengths, then does that match up with what the motion capture observes? Once we find a geometry that matches really, really closely, then we can say with some high level of confidence that that is in fact the geometry of the actual robot. And then we can say in Jugglebot's code, we can say, okay, base node 0 is at these coordinates. Base node 1 is at these coordinates. And then so on, so on, so on for all of them. We can say the default lengths of all of the legs are this, this, and this. And then every time we move the robot in the future, it will use those coordinates as the geometry of the robot. And then we should be getting very precise movements. In theory, hopefully. John is suggesting convex optimization. Sounds good. I don't really know too much about these sorts of optimization routines, but I suspect I'm going to learn about them soon. James says generational AI training would be how I would iterate a solution to that system of equations. Interesting. That might be similar to what one of the papers does. So this actually could be something interesting. Maybe once I generate that data set of the platform having moved around to a whole bunch of positions, I'll make that available, and then people can do whatever they want with it, and you can try different routines to see if you can get a better fit than what I managed to get. Also, on that note, actually, if anyone has any suggestions of where I should be moving the platform to, I am all ears. My thinking right now is just to do similar to what I had before, which looks like this. If it will open. Yeah, my thinking is to do something similar to this. Oh, where'd it go? It's apparently... What was that? How did that happen? Yeah, to do something similar to this, where I get it to move to a whole bunch of coordinates and then also try a bunch of different rotations at those coordinates. Yeah, that's my thinking. And I'll probably do like a Z one as well. Yeah. But yeah, I don't know. If you've got any other ideas, then I'd love to know. I don't think the sad face will be super helpful for this. For actual, alignment purposes. Definitely for validation. James says, reach out to YouTuber Code Bullet. He does a lot of this kind of stuff. Might want to collaborate. Interesting. I'll check them out. Yeah. Thank you. Yeah. I think I had something else to say on that, but I can't remember right now. Yeah, so I think this is a good step forward. I am pretty happy with how this is going. I'm very interested to see what the end result is, and I really, really hope it works. I would be so happy if we can actually move the platform to where it's supposed to go, and it actually goes there. Wouldn't that be nice? Yeah. Okay. I also, this week, have some thoughts on the hand tracking. So I'm thinking that we can put a ring of dots. So the same tape that I'm using to cover this, I'll just cut little dots out of it, and I can put a little ring of those around the inside of the hand in here. And that way, maybe we can have some level of confidence as to whether or not the ball has been caught by whether or not we can see the hand. Now, this is something that we've talked about a fair bit on this channel, is like, how can we know if the ball is actually in the hand? And there have been various suggestions with like pressure sensors and like sensing like with the hand motor, because the hand motor is sensitive enough. Like if I have it turned on and I'm like viewing its like different I don't know, like position, velocity, acceleration, current, if I'm viewing all of that stuff in real time, I can see, even if I just like very gently put the ball in the hand, the hand motor is sensitive enough to detect that weight. However, I'm not a huge fan of doing that. I don't really like the idea of having to rely on that when the whole thing is actually moving around, because it's one thing to be able to recognize that the ball is like, to be able to feel the weight of the ball when you're stationary, but it's another thing entirely to do that when you're actually like throwing and catching and moving around. So I'm not very hopeful that that would work too well. And the pressure sensing, I want to avoid running cables to the hand if possible. Also, not to mention the fact that future versions of the hand will almost certainly have a hole cut into the bottom of them, because that stops the ball from like rolling. Like right now with this hand, it's feasible that the ball can come in, roll off the bottom, and then shoot up the other side. But if you cut a hole in the bottom, that doesn't happen. The ball just like comes down and then just like rams into the hole. And that's what we want. We want to just like kill the kinetic energy of the ball as quickly as possible. So the pressure sensing, not a massive fan of. But maybe if we have these marker dots inside the hand, they should be able to be, I need to actually try this out, but they should be able to be seen by the cameras when the ball is not in the hand. And then my thinking is that when the ball is in the hand, the ball will be blocking those markers, and so we won't be able to see the hand anymore. So we can have some procedure in the code that says, yep, tracking the hand, we know the hand's position is whatever it's supposed to be. And again, we can use that to validate that the hand motor is in fact moving it to where it's supposed to go. And then if we cannot see the markers in the hand, then we can be pretty confident that the ball is in the hand. So hopefully, I'm thinking that at a minimum we can use this as like a backup check. If we think that the ball should be in the hand and we can't see the hand markers, then we should be pretty confident the ball is in fact in the hand. But there are other situations where like if we don't think that the ball should be in the hand, if there's no ball around and we still can't see the hand markers, then it's like, well, what's causing that? I don't know. Yeah, so how strongly we rely on these different inputs is something that we'll need to test out. But yeah, I think it could work pretty well. James is suggesting model divots for the marker stickers into the print so you know where they are. That's a good idea. So yeah, no, that is a very good idea. Yeah, that is a very good idea. I will do that. Yeah, thank you. Yeah, my earlier plan actually, which is what this hand is printed off to be, is you can kind of see there's like little slots in the top here, and I was planning to use the same like little strip that is wrapped around a cylinder, same as what I've done on the platform. I was planning on doing that on the hand, but after the Qualisys guy raised the concerns about like that only being like a rectangle and all of those related things, I'm now kind of leaning towards the dots. But yeah, the modeling the divots is a good idea. Yeah. Cool. All right. That's everything. Not quite, but there's some things that I did a little bit of. I know that I said that I wouldn't last week work too much on the ball launcher, but I've done a little bit of work on it. But I want to save that until it's a bit more complete, and I think it should be pretty cool. I'm very keen. I'm thinking it can go up here where the camera gimbal currently is, and then that way you can kind of just like launch from that spot down into Jugglebot. Would be pretty good. I'm very keen, very, very keen for that. But yeah, I wanna save that until I've actually come a bit further. But yeah, it's coming along. I'm very, very glad that QTM can do what I want it to do. It's big relief that it's as powerful as it is. I was kind of getting a bit like, like this isn't really doing exactly what I want. You know, I'm kind of having to like force a bit harder to get what I want out of this. But it turns out it was just a skill issue. And Philip, my guy, came to save the day. Yes, James says, it's amazing progress. Thank you, even if it feels slow. Yeah, some days it does feel slow, definitely, but, you know, is what it is. Integration is always where it gets hard. Yes, absolutely. I remember very vividly when I was starting out this project all those years ago, and I was watching like Stuff Made Here videos, and he would talk about integration hell, and I'm like, it's not that bad. I've got different components that I'm integrating, but at that time it was like the shitty like syringe Stewart platform with like integration into the code that makes it move around. Like that's, now I realize that's not the kind of integration that he's talking about. He's definitely referring to integrating complete different systems together. And yes, it is tricky. It's lots and lots and lots of little problems. But, you know, once we tick them off, this is what I love most about like engineering work, and I guess science as well. Oh, I think maybe more engineering, is that like once you've done something, once you've solved a problem, for most problems at least, it's solved, it's gone. And then you can move on to the next one. And eventually, you fix all the problems, and then there are no more problems, and it works. Also, I'm told. Yet to reach that stage yet. But yeah, it's getting there. Yeah, as always, if you have any thoughts on any of this, I would love to know. And yeah, YouTube comments are great for like short little comments, but if you've got a more detailed thing, or if you want to have like pictures or anything else, then yeah, head to Zulip and post wherever you want, and if it's in the wrong spot, I can just move it around. And yeah, cool. I checked my calendar this time, and I will in fact be on next week, which is good. And I'm not exactly sure what we'll be going through, but we'll see. We'll find out together next week. Cool. Well, I hope you all have a good time until then, and good luck with everything that you are doing. And yeah, I'll see you next week.